Finding an unknown side of a triangle using trigonometry is fairly straightforward. This is a revision from Year 10, but we need to go over it and just make sure everybody has this right before we move along. I've written out a number of steps here to make sure that you don't forget anything, because the main reason that people make mistakes with these questions is because they try and do one part in their head and they mess it up. So I'd encourage writing out everything as it is here. Now, step 1 may or may not be necessary. For a worded question, draw the triangle. If you're given the triangle, you're ready to go. But if you're asked about the distance from a flagpole or a cliff or something like that, then start by just doing a really simple triangle every time. Step 2, see which sides you have. Have you got the opposite, hypotenuse or adjacent side? And choose which trig ratio you're going to need. Step 3, write the trig equation. Now this is super important. A lot of people don't write this down. At this point they go straight to their calculator and you think, what are you going to put in there? You need to show exactly what it is that you're going to put in the calculator before you have any business reaching for it. So starting on this one over here, we have 40 degrees. X is the opposite side and 5 is the adjacent side. Opposite over adjacent, that's toa in our soccer toa. So we need tan. So when we write the trig equation, we write tan of 40 degrees equals opposite x over adjacent, which is 5. Step 4, rearrange your equation. Now, why do I need to rearrange this? I need to get x by itself. So at the moment, x has been divided by 5, so I need to multiply both sides of this equation by 5. Multiplying this side will give the x on its own, and I'm going to actually write that down on this side. And multiplying this side by 5 will give me 5 lots of tan 40. And I can write that without the multiplication sign there. At this point, I need to check what to do next. Check if the angle is 30, 45 or 60. Now why is that? Because we've already learned our table of exact values for these angles, for sine, cos and tan. So if you're dealing with one of those, I've got an example here that does, so I'll show you how that works in a moment, you will be able to work out the answer as a surd. And often it will ask you to do this and say, give your answer exact. So always think before you reach for your calculator, do I need a calculator or can I actually convert this to a fraction? If not, use a calculator. So 40 degrees, we need our calculator. So at this point now, we reach for the calculator and we put in 5 times tan 40. It's as simple as that. And the answer comes out, it's always going to be something long, so you need to, in step 6, check that your answer makes sense. So 4 and a bit, look back at your picture. If that's 5 and this is 40 degrees, would that be 4 and a bit? Yeah, that seems pretty reasonable. Now, if you've gone wrong, you'll often go really wrong and it won't make sense at all and you'll find your mistake by doing this. So this is probably the most important step of the lot. Check your answer makes sense. Now you need to round it off. If you haven't been told what to round it off to, choose something sensible and then add your units. So here I have 4.195. I'm going to say to 3 decimal places, and I'm going to say that those are centimetres. All right, second example here. Let's go through the steps again. We have our triangle. Which sides do we have? Well, from this angle, this is the hypotenuse, and this is adjacent. So we have A and H. So we need to use cos. So the first thing we write, cos of 30 degrees equals 5, because it's adjacent, over x. Now you'll notice here that there's a difference between these two examples, and I've done this on purpose. Every time you're finding a side, you're either going to write down your trig equation and see that the x is on the top, or you're going to find that it's on the bottom. Now if it was on the top, you can see what we did to both sides there. We just multiplied by what was on the bottom and it came out nice and easily. There's a thing you can do here to just switch these two. Now the reason I know this works, anytime you have something, let's take some familiar numbers. We know that 3 4s are 12, right? So if I have 12, effectively these are factors of 12. If I divide 12 by 4, I'll get 3. But if I divide 12 by 3, I'll get 4. Can you see how these two are effectively factors of this in this situation where you've got a fraction on one side and a number on the other? You can always swap those. And that's what we have here. This is 5 divided by x is cos 30. So 5 divided by cos 30 would also be x. And I sort of keep that in mind as a little trick, I guess, because it helps me go straight to the next line, switch these two, and know that x equals 5 over cos 30. Now you'll see here that what we get is quite a different looking thing from this one where we had something times sine, cos or tan. Here it's 5 over. So you need to make sure you get this step right. Now if you get confused by doing this and you want to take an extra line, that's fine. You might think, look, let's multiply both sides by x because that gets rid of the fraction. That'll give me x cos 30 here equals 5. And then to get the x by itself, let's divide both sides by cos 30. It'll still give you the exact same thing. But the more of these you do, you might realise you can sort of leave that line out and jump straight down to here, but just be careful. If you mess up, that's a potential place that you might do it. Now, we've rearranged it. We've got x equals something. We're not going to reach for our calculator yet because we've found that cos 30, checking, that is one of the ones we actually already know. I'm going to move over here so that you can see this a little bit more clearly. What we have now is x equals 5 divided by cos 30. Now, cos 30 is root 3 over 2. You'll need to recall that from the table of values that we wrote up, and we said we're going to memorise those. So instead of writing 5 over root 3 on 2, I'm going to write 5 divided by root 3 on 2 like that, because this just means divided by, doesn't it? And that way, when I'm dividing by fractions, I know that the easy way to do it is just to multiply and then flip the fraction. That gives me 5 lots of 2 over root 3. So the answer is 10 over root 3. 10 over root 3 what? Centimetres. Now I don't have to round this off, this is exact, but I do have to check that it makes sense. So it's probably handy at this point to just throw 10 divided by root 3 into my calculator and see that it's 5.7 something, and look at the picture and say, yeah, that seems to be about right. The other thing you could do to make sure you've got this right is to throw 5 divided by cos 30 into your calculator, and that comes up with the same answer, 5.7 something, and that gives you a bit of reassurance that you've done the right thing here.